Here we are on the RS website looking at the QUINT4 24 volt DC 10 amp power supply. This is the one we were just looking at on the bench. So as you can see, it's a lot more expensive than the alternatives. The other power supplies that we were looking at earlier on eBay, the cheapy ones are probably about $50 each, and the ones from, I'm just trying to find them, RS components for the meanwhile are about 100 to 150 pounds. So you're paying a bit of a premium for this power supply, one because it's smaller footprint, but also you're getting the NFC and the signaling outputs from it, which is all well and good if that's what you need, and that's great. I think there's a lot of uses for this. Now let's have a look at the technical specifications for it. It tells you all about it. There are 3 of them in the range here. We have the 5 amp, the 10 amp, and the I believe 20 amp version. Let's just have a quick look here. Please go down. So some of the features. You can, through the configuration, you can selectively trip the output of the power supply, simulating different kinds of circuit breakers, either by hitting immediately the load that you've specified or allowing a, say, 20% overload or even more. We'll look at the configuration as we come to it. We have the dynamic boost, where it starts up and it actually allows the load to consume more than the effective trip volt current is set to, so that, as it says here, you know, heavy loads, inductive loads and things sometimes take a little more current than, capacitive loads take a little more current on startup than what their normal operation is. Now you can either overrate a power supply to compensate for that, or in this case it's built into the power supply to be able to handle it. It's not a continuous load rating, but it's a boost capability, so that the power supply doesn't have to be over dimensioned, as they call it here, or overrated. There are signaling outputs that can indicate operating issues before they occur, things like the power output, monitoring your load and things. Robustly built, we've already talked about that in the previous video, that the enclosure for this is a very heavy duty metallic enclosure. It looks like an aluminum alloy of sorts. All of the heat generating components looks like they're bonded to it, so that there is ample heat dissipation through the case of the unit. We have a sleep mode for energy saving at the consumer end. What this means is that there is a signaling output. If I just open up a picture of the connector here and bring it in the we've already mentioned that there is a digital output, 2 of them, which are effectively digital voltage outputs, one of which can be configured for analog output. The other one, 13 and 14, are just open contact that can be configured to indicate different states. But you've got this remote REM input, which is an input to the power supply, and if you ground it or reduce the resistance between it and signal ground below a certain threshold, it will actually shut down the power supply, not the input to it, but just the output, so that you can effectively have a standby mode. So that's very useful if you have the need to actually minimize the amount of power that's being consumed by something. So there are a number of different ones available, the smallest one being the 24 volt at 5 amps. And you can see here we're talking about the boost capability of it. The 5 amp unit, it can have a static boost up to 6.25 amps, but also on startup you can set it to allow a dynamic boost up to 10 amps for 5 seconds to allow heavier loads to get initialized and running and then settle down to their normal load. The fuse braking, the ISFB, can be set to as much as 30 amps, kind of simulating the way a regular metal fuse would behave. If you're very, very close to a fuse rating, say you put a 10 amp fuse in, if you were running at 10 amps, it would get hot, but it wouldn't necessarily blow. But if you put through a lot more current than that, it would trip very, very quickly. So you can actually set up a fuse break of 30 amps or various other configurations, and depending on which power supply it is, obviously this 30 amp one is for the 5 amp power supply. If you're using the 10 amp one, which is the power supply we had on the bench here, the fuse breaking can be set for 60 amps after 15 milliseconds. And if you're using the 20 amp version of the power supply, then you've got 120 amps surge fuse breaking capability. Dimensions, don't worry about. So signaling, this is the capability that you have on these outputs, output 1, output 2, and also 1314 here. As you will see here, you've got the relay on 1314, you've got out 1 and out 2, which are both digital. But as I already mentioned, out 2 could also be analog. So logic 1 being anything between 16 to 24 volts DC. You can load this up to anything less than 30 milliamp load, and these are the configurations you can actually do with it. So output digital 1 can indicate the output voltage is present. Output 2 is that there is power being delivered. Output 1314, which is the relay, indicates output voltage is okay as well as default, but you can configure it to be completely different as well. For instance, digital output 1 could indicate output voltage, output current, output power. Also, it can indicate operating hours, early warning, high temperature, alerts, and voltage limitation active. So if you go over, if there's an over voltage detected, it can alert, and that can be on either of the three outputs, the relay, output 2, or output 1. And you can also have indicating input AC is okay on input on digital output 1, but not on digital output 2. Now, one of the questions you may ask is, why is it important to monitor your power supply closely? Well, if you want to have a preventative maintenance scenario where, for argument's sake, your Phoenix power supply is driving a motor, you may know that your motor will pull about 100 watts of power during its normal use. So you'll have a certain area that your power supply is going to operate in, and if let me just go to draw mode here on my screen. If you have I'm just going to do a graph here, get a little bit rough and ready, but bear with me. So if you have, say this is 240 watts total, you know over time that your power supply is going to be sort of drawing, roughly 100 watts. And maybe it'll go up and down depending on the load and things like that. That's all well and good, and it allows you to, that's your normal operating threshold. Now, the analog output using out 2, you could be monitoring with a PLC, and you could have some kind of alert set so that if the power consumption goes, say, above, let's just say this is 200 watts, you could have it create an alert for you, so because it's going above a certain threshold. You could also be monitoring the current of the power, or the power being consumed by the motor, and looking for trends. So this is the, you're coming along, the black one is maybe the previous month, and the green one is now the current month, and then you've now noticed that it's starting to maybe do this on the power consumption. And it hasn't hit that magic limit yet, but what that could indicate to you is that the power supply is starting to provide more and more power to the motor, and this could be caused because maybe the motor is wearing out. The bearings are starting to get dry or worn, and it's requiring more power to maintain the speed, or or whatever it happens to be driving. Or something associated with that. And I'm talking about it being a motor hig, but it could be anything that could, even though it's not gone over an alarm threshold, could be indicating that something is starting to fail. And by monitoring the load, whether it be the current or the power or whatever it may be, over time and putting it into your analytics, you can actually decide to do some preventative maintenance. So maybe when it gets to this level, you would schedule a it's now hit this point, you schedule somebody to go in and maybe do a service on the motor or replace some components or whatever it might be to remediate the problem and get it back into its normal operating range. And that's something that if you were going to do that with external devices, you would have to have those all fitted into the rack. It would have to be all configured in and calibrated and everything else. When you buy this Phoenix Contact QUINT4 power supply, all of that's built in for you, which is really, really handy, because all you've got to do is connect it up to your monitoring device. And that monitoring device could be simply a meter on a panel that just indicates the power usage, and somebody goes and writes it down once every day or two. Or it could be more sophisticated where it's feeding into a PLC or some kind of other remote monitoring device and feeding it up to a control center where it's actively monitored and alarmed and reported upon, so that you can actually look at trends over time and everything else, a bit like this rough and ready graph we've just done. So here we have my phone screen, so let's just get it across to start up the Quint Power application. Now I've already shown you the reading NFC and things like that, so what I'm going to do is go straight into a new configuration, and we're going to pick the power supply we have, which is a single phase 24 volt 10 amp unit. We can adjust the output voltage here, 21 volts, so we can say maybe we know we got a 2 volt drop, so we can just set that immediately to 26 volts. This is a lot more convenient to set up than pressing the front panel buttons, which only increments and decrements a little bit at a time. We can lock the buttons on the front panel. This is, remember I said you can actually lock out all the buttons. This is where you do that. So if you turn this on, then nobody can do any adjustments on the front panel, which means that you are protecting the environment from any accidental or deliberate fiddling by people. Somebody walks past and says, oh, I just tweaked that voltage up a little bit. Well, they can't do it if you lock it out. They would have to come along with a smartphone, smart device, and enable it before they could do that. Parallel operation is where you put two power supplies in parallel in a fault-tolerant kind of mode. Characteristics, these are to do with tripping and things like that. So this is the UI Advanced that we have here, where we have a static boost, we have a dynamic boost, and we have a selective fuse breaking. So in static boost, I don't know if you can just turn it off and on here. Yeah. So each one you can just turn it on and off at this point here. These basically control how the virtual fuse is going to behave within the power supply and whether it can deliver more power to the load or not for a given periods of time. In Smart Hiccup, it allows these intermittent boosts, and in fuse mode, if that's the way you want to run it, you can have the trip current. Now this is calculated partly based on what the voltage output is as well, because I think it looks a little bit on power. So that's why this is saying 9.2 amps right now. I think if I go back and set the output voltage to 24 volts, and we go to here, you'll see that now it's 100%, because it's, even though you're specifying a current, it's really looking at the power output, the limit of what the power supply can deliver. And you can specify how long it's actually allowed to operate above the iFuse rating before it will trip. So you could say, sorry, up to 12 seconds. I'm trying to say 500 milliseconds here. So you could say 0.500, so 500 milliseconds if you want, or you could say I'm going to allow it to draw 10 amps or over 10 amps as long as it's limited to less than 5 seconds. That's in fuse mode, so you're making it act as a fuse. The smart hiccup has no adjustable parameters, it's just automatically figuring things out for you, so little boosts of current consumption, etc., etc. And then the default one, which is UI Advanced, has got all three of these effectively in play at once, and it's automatically figuring things out for you. Now the signaling, which is a little bit of what we were playing with earlier on the power supply, you've got your three outputs. You've got output 1, output 2, and output the relay, which is contacts 1314. So you click the one you want to use and you can indicate, this one is purely digital, so you can indicate that the output is high or low if the output voltage or any of these, output current, output power, operating hours, temperature, input voltage, or over voltage protection. So if, we'll have a quick look at each of these. So if the output voltage is greater than 90%, alright, which means that that's a good state, obviously, in this condition, and you can change that percentage, of course. So this would be like a low voltage protection, and you can change that output to be low if you want. It doesn't matter, it just depends on what your monitoring system is doing. Output current, you could say that if your output current is less than 100%, so 10 amps, so if it will indicate high, so it's saying your current is okay or your voltage is okay. Power, right, less than 240 watts. I don't think you can change that one to be anything else. Operating hours, so you can say if the operating hours is less than so many hours, then this output will be high. So what you're looking for is perhaps you could set 50,000 hours, and after 50,000 hours it's going to drop this output low, and maybe that will indicate to a maintenance crew that this power supply has been in service long enough and it really should be replaced, or at least given a check over to make sure it's still okay. That's operating hours. So you've also got temperature. It's just if the temperature is okay. You can add other conditions to these as well, so you can stack things. So if the temperature is okay and the input voltage is okay, as an example, then that output will still stay high. So you can have a little more sophisticated alerting and things like that on them. On output 2, we have the choice of the digital output, which has all the same choices as far as when it's on digital is concerned. Okay, they're all the same ones. But if you go to analog output, this is what we did on the unit on the bench a little while ago, you can have the analog output for 4 milliamps usually represents 0 and 20 milliamps represents something else. Then you can monitor either the output voltage, the output current, or the output power. I showed you both the current and the power when we were looking at it on the bench. So here you can actually have some feedback, maybe so that it can tell a PLC or something else what the actual output voltage is on the power supply. You may want to monitor that. I mean, it's less likely in this case that you would actively monitor it this way, because you're setting the voltage and it's fixed. It's not like a bench power supply where you're always adjusting it. But you may have a reason to monitor the output voltage, and this is a way that you could do it. But you only get to choose one thing that you're monitoring on that analog output. So my choice typically, and it depends on your application, would be probably to monitor the output power. Okay, and you can set, this is a 4 to 20 milliamp standard industrial current loop, and this is how you do it. Now, if you were normally running the unit at say 8 amps or less, maybe you only had a 200, you wanted to get the maximum scale for your power monitoring, you might change this, for example, to just read 150 as an example. And now what that's going to do is 20 milliamps is going to represent 150 watts. So if you go over that, you're not going to get any more reading, but you will have better resolution now within the operating range. Maybe you're nominally running at 100 watts. You've overspec your power supply for lots of different reasons, and you've set your scale to be 0 to 150 watts. If you want even more resolution, you could decide to perhaps have this scale set to 200 watts there, and maybe this one set to 100 watts. So you've narrowed your, now you've got 16 milliamp range that represents only 100 watts of power differentiation. Yes, you can't see what's below that, but if you're below, say, 100 watts, you know there's something seriously wrong. And if you're above 200, you know there's something wrong as well. So this could monitor actively in between your normal range, and if you go outside of it, you could have some kind of logic in your PLC or your control system that will then trigger some kind of alerts and things. So that's the analog out on the signaling. And then your last one is your relay, and again, instead of high and low, you've got open or closed because it's a relay, not it's a pair of contacts. And you still have your same basic set of parameters, so output voltage, current, power, operating hours, temperature, voltage, overcurrent protection, that then can set these various thresholds, and you can again extend the condition. So overall, these QUINT4 power supplies, they've got quite a lot of adjustments. They've got the ability to lock out the front panel control. They have the ability to participate in preventative maintenance by providing you operating parameters on effectively a real-time basis that you can feed into trend analysis and everything else, and look out for deviations from the norm that could then trigger a maintenance visit to the system, so that you can figure out why it's drawing more power or less, and remediate that and fix it. So that I think that's probably about everything right now that I want to show you with these Phoenix Contact power supply. You do pay a lot more for it. If I bring up the website again, as I said, it was where is it? Yes, there. So this is the QUINT4 24 volt DC 10 amp power supply. It's 187 pounds. So that's probably about $250 to $300, which is quite expensive. When I was looking on eBay for the sort of 24 volt 10 amp or 5 amp power supplies, they were typically about $50, so 30 pounds, significantly less. But as I said in the intro video about power supplies, you get what you pay for. When you're buying something like this, you're getting manageability built into it. You're getting a certain level of security. You're getting reliability and better quality testing and everything else. When you buy one of those cheap eBay specials, then who knows what you're going to get, and if you want a replacement or some warranty work done, good luck. But if you don't need all this monitoring and everything else, then you do have the alternatives where you could go to a Meanwhile or something like that. I mean, if I just go in here, RS Pro power supply, 24 volt 10 amps. Let's just have a quick look what the prices are as of now, to just make sure we're just limited to RS Pro, which we are. There's 5 power supplies in here that match our criteria, and the one that I have on the bench, you can see here, it's 98 pounds, so it's almost 100 pounds cheaper. It's twice the size physically, and it doesn't have the analog output for monitoring. It doesn't have the alerting. It has an LED on it that says I'm good, but that's really all it has. So this is going to be a fairly reliable power supply. It's going to work well for you. Meanwhile, is a very, very good make, but if you want to have that next level of manageability, and you want to have proactive fault detection. So if your power has gone up and you're consuming more than you would normally do, get somebody out there to have a look why. One of these other power supplies won't do it for you. You would actually have to add separate current and voltage monitoring devices to this in order to get the same things. And how much would that cost you to add into here? Not just the manpower for wiring it all up and installing it, but calibrating it, testing it, the additional rack or panel space that it would consume to do that. And that's one more part that you would also have to keep on the shelf in case of problems, or it's one more part to go wrong, and take your system offline while you replace it. So by having all those basic units in one device, it means that you've got one-stop solution. You can, as we've shown you, you can configure it to monitor different things and to trip on different levels and everything else. So I would suggest that if you really have those more sensitive systems where you want to have the elevated monitoring, preventative maintenance capabilities and things like that, Phoenix Contact definitely looks like a power supply that you should have a look at. I haven't seen any other power supplies so far that have the ability to program its parameters through an NFC smart device. There may be some that have network connections or RS-485 and things like that. I just have not had them in my hands to review yet. This is probably the most advanced DIN rail mount power supply that I have currently had on my desk. So I think that pretty much completes the overview of the power supply. I'm not going to start putting and testing its transient response time and all these kind of things. You're buying power supplies from reputable sources. In this case, you really don't need to start testing all of those things. You can just look at the data sheet. What is really interesting to this power supply and what sets it apart from pretty much any other one that I have seen so far is this extended signaling capability, the configurable parameters of how it operates, the ability to lock out the front panel from tampering and things like that. It makes for a very flexible but pretty secure power supply that you could integrate into one of your control systems, whether it be motion control, security, whatever else it may be. So I like what I see, and I'm going to be putting this into one of my solutions. I'm not sure which one at this point in time, but I will integrate it into something so that we can actively see what the power requirements are being drawn from it and things like that. Maybe my smaller CNC, I could use this for driving the stepper motors and any of the control logic that works on 24 volts. That would allow me to actively monitor how much power the CNC is consuming in a real-time basis. So that would be quite interesting. Anyway, I think I'm starting to repeat myself, so I'm going to call it quits for this review and overview, and I will see you next time. Hope you enjoyed that. Hope you found it interesting. As I said, if you have a need for this, then you'll find it more interesting than somebody that doesn't. Hopefully you've also gained a little bit of an understanding why, even if a power supply is a lot more expensive, there are a lot of situations where that increase in cost is definitely worth it, even if it's because of the additional capabilities that it brings to the table without increasing size or complexity of wiring and things like that. Anyway, that's it. So see you next one. Bye.